Welcome to another episode of Old Guy Physics. This is the second graph that we covered in the class here recently, and this is a velocity time graph. And so, again, there's important information that we can pull off this graph that I think is relatively easy for us to see, and I'm just going to review that right quick. Number one, the slope. Okay, on the distance time graph, the slope gave you the velocity. But on a velocity time graph, the slope is going to give you the acceleration. Okay, so everywhere we can solve on this graph for a slope, it will tell us something about the acceleration. And so again, if we come over here, we came over 4 and we went up to 16. So the slope is going to be 16 over 4, which is 4, and this is a positive 4. So this is positive 4 for the slope of this line right here. And again, like we said in the previous problems, anywhere that it's flat, the slope is equal to 0. Well, on a velocity time graph, if the slope is 0, it means that there's 0 acceleration, but that also tells us that 0 acceleration is equivalent to, or is the same thing as saying, constant velocity. So during this period of time here and during this period of time here, the object or the person was moving at a constant speed. Now, if we look at this spot right here, it goes down 8 and it comes over 2. And so the slope there is going to be 8 over 2, which is 4. But because we're going down and to the right, this is going to be a negative 4 meters per second squared right here. Now, in the definitions in the vocabulary that we talked about earlier in the week, we said that positive acceleration means speeding up. Negative acceleration means slowing down, okay? And so I thought about a scenario that this graph would represent. Suppose that you were sitting at the traffic light here at the origin, and the light turns green, and so you're going to speed up until you get to a speed of 16 meters per second, which is a velocity. When you get to that speed, perhaps that's the speed limit in meters per second, and so you're going to be traveling at a constant speed for a period of time. And then at this point right here, you see a sign that says school zone. Well, we all know that we got to slow down to a new speed limit when you're going through a school zone. And so they're slowing down and they reach a new speed limit. And for this period of time, they're moving at a slower speed, a constant speed. And that would have been 8 meters per second if you read it off the graph. Now, that's all of the things that are related to slope. Now, like on the other graph, one of the questions was, what was the total distance traveled? Well, that has a particularly interesting way to solve that, because we're going to solve for the area under the line. And so let me grab a different color right quick so you can see this a little clearer. If we come down here, you can see that we formed a triangle. If we come down here, you can see that we formed a rectangle. And let's suppose, and of course we could form a triangle here, and we could form a rectangle here, and so on. But let's suppose that the question on the worksheet says, what was the total distance traveled in the first 8 seconds? So we're interested in all of this space underneath the line to the first 8 seconds. Well, if we refresh our memory, the area under the line is equal to 1/2 base times height for a triangle. So 4 times 16 is 64, and half of that is going to be 32. And then we've got 4 times 16 is 64. And so the area for the triangle was 32. The area for the triangle, or for the rectangle, excuse me, was 64. And so the total distance traveled is going to be 96. So from here to here, the total distance traveled would be 96. Now, in the previous problem with distance versus time, they also ask us a question about displacement. In a velocity time graph, it does not actually indicate to us whether the person is moving in a straight line the whole time or whether he's moving, you know, in a curved pathway, because that's just not indicated. So most of the time when we ask for the distance traveled, the displacement and the distance traveled would be the same, unless otherwise, because this is speeding up and this is slowing down, but we could all be traveling in the same straight line, like down Highway 78, and so that would all, the displacement and the distance would be the same. If you have any questions like before, see me in class, and we hope you have a blessed day. Thank you.